I'm here to present our solution, our quite innovative solution called Network Cloud. Now, our solution is quite different from other solutions that you will hear today and tomorrow because we tackle the core of the IP network. What Roy said, the SP core, this is the section in the slides of Roy. And when we talk about the core of the IP network, we first talk about scale, about the ability to scale. Now, first, I want you to be aware to this solution, this direction, but even more important, because we are a lot of discussions here about new services, about the way to introduce new services, and as you will hear, we develop a new and open platform to introduce new services to the network. I want you to think how you can use this technology and this new platform to introduce new services in your networks. But first, let's look at the challenges of the service providers when we talk about their IP network. So first, we talk about their cost model. So today, the demand for the network increases, but still, their margins are squeezed. And it shouldn't be this way. Think about it. Usually, as a seller, when you have a product and the demand for your product increases, you can get higher margins. But when you look on the network of the service provider, you see that when the demand increases, the margins are squeezed. When you look at their operational aspect, you see network that was not changed for many years, and it's become more and more complex. And when you're looking at the revenue side, we see that all the service providers want to introduce new services in order to generate new revenue. The problem is that it takes time. Just think how many systems you need to touch and change in order to introduce new services. You see how long does it take to introduce new service. Let's just look even deeper. What are the reasons and the impacts of these challenges? So the demand for the network increases like skyrockets. 5G networks, video that goes from high definition to 4K, and now from 4K to 8K, and gaming and everything. So the demand increases. The revenue from the end users remained flat at the best case. So the revenue per bit is falling, right? The cost per bit of the service providers, the cost per bit declines, but not fast enough to compensate on the dropping of the revenue. So as a result, you get a squeezing of the margins. Now, it's more important to understand the reason for this behavior. And the reason is in the cost structure of the network. And today, the cost structure is a tight coupling of the expenses with the capacity, with the growth. So we need a new model that disconnects this tight coupling between the capacity, between the growth, and the cost. How many of you hasn't seen this diagram for at least 50 times? Right? This is true. The network model was not changed for many years. And during these years, more layers were added, more functions. And each function came with a new system, new hardware, new vendor. Now, it's interesting that in many cases, and I'm talking about the central locations, you see many of these functions at the same location. So you can see an edge router next to a peer router, next to a peering router, and are all at the same location. So the packets needs to go from this router to that router and to the next router. And it adds delay and latency it takes extra power just because you need to go through all these systems. It adds complexity. So what can we do with all these three challenges? Now, everyone is talking about cloud and networking. And it makes a lot of sense when you see the great benefit the cloud brought to the data centers, the new service opportunities. So why not to take the cloud technologies to the networks? And we know it, everyone do that. And it works well at the edge of the network. But what we found that it doesn't work well when you're trying to go to the core of the network, where you need the high scales. And there is no, and from our experience, it doesn't work just taking it to the cloud. Just bring a cloud infrastructure and put the core functions on the cloud. So we need to think about a new way to do that. And what we found is instead of trying to take the core functions to the cloud, maybe we should do it other way around. Maybe we should take the cloud features to the network. But before we are trying to take these cloud features, we should better understand how the cloud helps the hyperscalers to address these three challenges in the data center. So I'll just go through the main concepts, the main attributes of the cloud that helps the hyperscalers in the data center. So before the cloud, each application, before the cloud in the data center, each application had its own server. When you wanted another application, you had to bring another server and another server. So we have the virtualization layer. And the virtualization layer disaggregated the application from the hardware, the software from the hardware. So now the compute and the memories became a resource, and the resources are allocated when and only when the applications need them. And if you disaggregated the software from the hardware, now you can start to share resources, which is a big feature of the cloud. So instead of allocate the maximum resources for each application, resources that will serve only the peak performance of this application, it's better to share the resources. So you can allocate enough resources to serve all the applications that are active at any given time. It's a big difference. Instead of allocate the maximum, the sum of the maximums, you can now allocate the maximum of the sums of the resources. So we have a sharing of resources. And if you already disaggregated the software from the hardware, you don't need to go and buy strong servers for your applications. It's better to go for small and cheap servers and buy many of them. And if you buy many of them, why not to buy them directly from the manufacturers, from the ODMs? So they switch to white boxes. And they developed orchestrators, right? And the orchestrator took care to automate it, the entire processes. So now if you want a new application, you just tell the orchestrator how many resources you need and when, and it's done automatically. So they simplified the operation. And they built microservices and containers in order to enable quick development of new applications, of new services. So we see how the cloud addressed all the three challenges that we have on the service providers using cloud. But the problem, as we said, that we can't take the core to the cloud, so we need to take these principles to the network. So there are other trends that started in the network, and I'm sure you're aware to them, beside the hyperscalers clouds. So we see the trend of the SDN, the the network that became more and more software-centric with virtualization of network functions. And we see it very popular. We see, and we talk about it in the 5G networks. Other trends is network building blocks, the shift from proprietary hardware to network white boxes. And network white boxes are slightly different from the white boxes in the data centers because they include networking chipsets for networking. And we see this trend so far in the switching market, when you see solutions that use white boxes for switching. So DriveNets took all these three trends together in order to create the network cloud. So what is network cloud? So network cloud, we disaggregated the monolithic router in many different layers. We disaggregated the chassis-based router to a virtual chassis, a cluster of pizza boxes. And now you can scale these virtual chassis as you need, just by adding more pizza boxes. We disaggregated the data plane from the control plane. So the control plane of the router now runs on a different server. So now the control plane and the data plane of the routers can scale independently. And network cloud technology, everything was built with cloud-native technologies, with containers and microservices, so you can easily develop new services. And everything was made with low-cost pizza boxes. So we have two building blocks. We have the NCP, which is the network controller packet processors with the interfaces, and we have the NCF, the fabric part. Now, the beauty of this solution is that by just using these two building blocks, you can create cluster at almost any scale that can run any service, just by using two building blocks. And when we develop the routing, for example, the routing features almost written from scratch in order to run on a cluster over a multi-boxes solution. So it is a combination of the white boxes, of the control plane, and the services. Now, the structure of these boxes is also part of the story. So when we started DriveNets, we thought, why not to implement network cloud on a standard x86 servers, like all the cloud implementations. And we developed the product over standard x86 servers, but we found that as I started, the price per bit is too high. You can't take core functions and just run them on x86 standard servers. So today we work with Broadcom's chipset, with Jericho 2 and Ramon, who know the names. Now with these chipsets, each NCP can scale up to 4 terabit per second. 4 terabit per second. And today we have two flavors of the NCPs, one with 40 ports of 100 gigabit per second. The second one is 10 ports of 400 gigabit per second. Just last week, we announced that the 400 gig flavor started testing in a tier one, in a lab with tier one service providers. So now we have two flavors of this solution. So if we zoom out and see the impact of this solution on the entire network, we see how simple it is. And it looks simpler because it is. So now we have clusters in different scale, all made from the same building block, all over the network, with just different services. You have a single software stack across your entire network. All the difference is about the scale and the service you run. So you get a unified and simple model that you can automate the entire processes and streamlines the operational features and processes. But if you remember, I said at the beginning that when you look on the cloud, it's not just about the simple, it's about sharing of resources. So to see the full benefit of this solution, of network cloud, you need to look at how many routers it replaces. So if we started this and say that you can have in a single location, you can have multiple routers for different functions, now you could have a single network cloud. You can have a single network cloud with different features, with different services. So we replace 2 or 3 routers with a single network cloud with different services. So we talk about the simple operation. I just show you how we can share resources in order to reduce the amount of hardware you need per location. But it's also ready for generation of new services. And network cloud services are not limited just for routing services. It's an open platform using standard tools that is ready to run any service on any port. It was written with cloud-native technologies, new services running on different containers. Everything was made with standard software tools in order to enable quick development of new services that can run on this platform. And taking into account that you can have this solution across your network, you see a simple platform where you can introduce new services end-to-end, not just on the edge of the network, but end-to-end through all your network. So we talk about using low-cost white boxes. We talk about simple operation. We talked about sharing of resources. We talk about sharing of resources. So just want to show you, so I want to continue, I want to show you also the telco grade features and how we use the orchestrator. But before I go to the more technical features, I want to show you how this solution can change the economic model of the service provider. So we took the disaggregation to the business conclusion. We are a software model. And the software is all-you-can-eat model. So the service provider will always pay the same annual license, flat number. The only part that is scales with the demand is a low-cost white boxes that the service provider buy directly from the ODMs, which keeps them in a cost-plus price. So we disconnect the growth from the cost. If you remember, that was the goal, a new model. So even though you have the demand increases, the costs are disconnected. So the impact, it's a significant impact on the COGS of the solution. So if we get back to the 3 challenges we started with, remember, we have the 3 challenges. So now we have a new economic model that disconnects the cost from the growth. We have a simple approach of operation with common building block and single software stack across your network. And we have a platform that is ready to introduce new services very quickly and to generate new revenue. So we see how network cloud, in the same way the cloud helps the hyperscalers to address these three challenges in the data center, you see how network cloud address the same challenges in the service provider network. But because we talk about service provider, we need to talk about 5 nines, right? Telco grade. So network cloud was designed for multi-layer resiliency, which means that, of course, you can deploy it in 2 clusters like other routing solutions when you have 2 clusters in separate locations. But inside the cluster, all the hardware was designed with M+N redundancy, which means that even if you have multi-points of failure, you still have no impact on the performance of the cluster. It can be a failure of one of the boxes or failures of links between the platforms. You still you can maintain the same performance even if you have multi-points of failures. The network cloud controllers, where the control plane is running, is also runs in active standby mode over 2 servers. And if you want it to even a better availability, you can take these 2 servers and install them in 2 separate locations. So you have even better high availability. So you see that if we talk about telco grade, network cloud was designed for multi-layer resiliency for telco grade availability. But we can't complete any session here without talking about the orchestrator, right? So network cloud includes an orchestrator. And in the same way, in the cloud, in the data center, we saw that in order to scale, you must automate everything. Network cloud was built from day 1. And as Javier said, it must be designed from day 1, right, for a zero-touch provisioning. So network cloud was designed from day 1 for zero-touch provisioning, and that everything must be automated. So the orchestrator takes care for all the life cycle of the solution, from the initial installation of the solution, from the monitoring of the KPIs, from the fault management, for the life cycle of the services. Everything is taken care by the orchestrator. Now, I just want to give you 2 examples. What do we mean when we say zero-touch provisioning? So when a new white box arrives from the manufacturer, it's blank. There is no software on the hardware, and it's part of the management of white boxes. So when the white box arrives, it's just connected to the internet and locates the orchestrator. And the orchestrator automatically installs all the softwares, all the operational systems that are required for the network cloud. But not just that. It also sets all the security policies that are mandatory before you can connect any box to the network. You must set the security policies. So only then the box is ready for connecting to the network, and everything is done automatically. No manual process. Now the box is ready, you can connect it to the cluster if you want to scale out a cluster. And again, when you just connect the box physically, connect the links of the box to the cluster, the orchestrators immediately downloads all the policies and the configurations to the box with no manual process. Now, if you, at this point, go to the dashboard of the orchestrator, you will see now you have a new resource, more ports where you can apply the services to. So this is part of the automation, the zero-touch provisioning, and to the full automation of the service. How much I have? 20 seconds. So I just go over all the features and the capabilities of this new solution. And you might think, and I think it's a valid question, okay, how do we migrate from the current architecture to the new architecture? Because network cloud is a big change in the way the network is built and operates. And we found that the best way to do the migration is what we called growth-first approach, which means at the beginning, and because the network cloud interoperates with the existing devices, at the beginning, just let network cloud handle the growth of the traffic, the new traffic. And since traffic increases about 20–30% a year, it's okay. Because few years later, after the service provider gain confidence in the solution, and by this time, most of the traffic is handled by network cloud anyway, only then start to think to decommissioning the old technologies. So this way you have a realistic migration plan where you take care for the risk of moving to the new architecture. So that's it. This is a word about DriveNets. We believe this is the future of the core of the service providers. Network cloud does to the networking what the hyperscalers did to the data centers. Now it looks like a future, but it's happening now. Thank you for your time. I'm here with my colleague, Nick. If you have any further questions or if you want more information, feel free to ask us. Any questions now, or we are out of time?
Get some questions that have come through. So I guess your targeted customers is like service providers?
Yes.
So let's service provider, I'm going to replace my Cisco box with your box in my network in 3 years?
Yes, why not? This is a vision, yes.
All right.
Do we have time or? So you asked about the flat software license for cost over 5 years period. What is the support model for those solutions in terms of OpEx cost over this period? Okay, it's a good question. And it's a question that you get this question for all these disaggregated models. But in this case, DriveNets take responsibility for the solution. It's not that we will take care for all the solutions, but we will be the one that gets a call. Now, you need to think about network cloud as an ecosystem. So we provide the software. The hardware is purchased directly from the manufacturers. And the model is slightly changed between the customers. There are customers that want SI that will take care for this support. There are others that want DriveNets. We are still working with potential customers to see how exactly to build this support system. What exactly is NCF Fabric? It's just high-level switch. So these white boxes, so they're based on the chipsets. You have a chipset for the fabric and chipset for the NCPs. So it's not a typical switch. It's something that works together with the NCP. They have a protocol, propriety protocol that works between the NCPs and the NCFs, and together they build the virtual cluster. Are any of your APIs standard, or are they all propriety? So the virtualization layer of network cloud and the communication is proprietary to DriveNets. It's what we bring. But the API from the network cloud to the world is going to be standard. We are not going to, it's not going to be proprietary. Okay, thank you.
Thank you.
I'm here.